Hello, my name is Mateo Torrejon, and welcome to Lab 3 Oscillations for Physics 2211, Section A. So in this lab, we will explore the oscillations that occur with a spring ball model that is dropped from a height, and then the point of this lab is to observe these oscillation movements in the spring as well as the motion of the ball attached to the spring. So what we did is that we had a video that we inputted into Tracker to track the position over time, and we put that data into a glow script model that allowed us to compute that into a specific model, and then the results were that the system's total energy aligned with the energy principle since the energy remained at a constant zero throughout the whole experiment. Alright, so on to main physics ideas. We can start off with Newton's law, specifically Newton's second law, the law of acceleration, where the acceleration of an object depends on the net force acting on it and its mass, described by the equation F is equal to ma, F net is equal to dp dt, and m is equal to m delta v divided by delta t is equal to ma, as well as the force due to gravity, where Fg is equal to 0 negative mg0, the spring force, where F is equal to negative ks, L minus L naught times L hat, the kinetic energy, where K is equal to 1 half mv squared, the gravitational potential energy, where Ug is equal to mg delta h, the spring potential energy, Us, is equal to 1 half ksl minus L naught squared, and the application of the energy principle, which we will see later on, where delta E is equal to K plus Ug plus Us, which is equal to 0. And as well, we can use the position update formula, which was used in the tracker, and the velocity update formula, which is also used in the tracker. So this is the tracker where we inputted this video of this person dropping a ball from a certain height with a spring attached to it. And then we recorded the positions over time in order to create a set of data that we inputted into an Excel sheet. And then so on the left is an image of the tracker, and on the right is the positions over time of the ball that we used with the tracker to get there. And so this is the glow script code that we use, where we have the system properties and the initial conditions, where we change the mass of the ball, the position of the ball, and the velocity of the ball, as well as our t and our delta t. And then on the right at the top, we have the gravitational constant, the spring constant, as well as calculating L hat, and the displacement. And then we have our kinetic energy, we have our gravitational potential energy, we also have our spring potential energy, and as well as the total energy. And at the bottom right, we have our loop, which allows us to calculate the position of the ball over time using the position update formula and the velocity update formula, which also allows us to use the total energy of the system to calculate the energy at the specific positions that are calculated by the code. So these are the results that we got, where we have the x position versus time at the top, where we have our code that we got with the tracker, and then we have our experimental data, so we can see that it's relatively similar, which is good. And then at the bottom, we have the y position versus time of our model versus the experimental. Again, it is similar, which means that we were able to input and get out good data from the tracker, as well as compared to the experimental, showing that we had adequate results. And so as we put these two graphs together, we can get the change in energy versus time and the change in energy, where we have our delta K, the delta U graph, as well as the delta T and the delta E, where you can see everything that we needed to see for this curve. So we can see at the middle we have our E, which remains constant over time, which will become important as we look at the other question. So for discussion, what does it mean? Yes, we satisfied the energy principle because the total energy change in the system should be zero because the surroundings do not have any effect on the system itself. So the reason for this is that because the system includes the earth, the spring, and the ball, there are no surroundings at all. So it does satisfy the energy principle since our delta E is equal to 0. And we can see this from our graph, from our results, where we can get that the E, we have the orange line remains at 0 the entire time, indicating that we did satisfy the energy principle. For the second part, for the calculation of oscillation time period T from x position and y position data, we saw that for x position data, the time for it to take one oscillation was 1.7 seconds, and for y position, it took around 1.5 seconds. Thank you.